Okay, 3.5 is about 5-number summary and box plots. There's actually not a whole lot of new information here. It's mostly just a summary of some of the stuff we did in 3.4. And we're going to talk about box plots, which are a way to display the quartiles in a graph, graphically. So looking at 3.5. So it says the 5-number summary consists of the following measures, right? Minimum, and then your quartiles, and then your maximum. And when you're giving a 5-number summary, you should give it in that order, okay? So let's determine the 5-number summary of the data from 3.4 example 6. So that was this, the Highway Loss Data Institute, right? Collision coverage claims business, right? So we've already done all of the work on this problem, so I'm just going to steal the work that we've already done, right? The 5-number summary is going to consist of the minimum value, which is 180. And Q1, Q2, Q3, which we have right here, right? So 735, 1805, and then 4668. And then the maximum value, which is 21,147. Okay, so there's the 5-number summary from example 6, and from example 7. Oh, example 7, that's even easier, right? So the 5-number summary is going to be 20, 28, 32.5, 38, and 40. Okay, minimum, then the quartiles, and then the maximum. Okay, 32.5. Okay, so that's that one. So 5-number summary, pretty easy. Now box plots. Okay, a box plot is a graph that displays the 5-number summary along with any outliers. Box plots are used, actually they're used in a whole bunch of places. I'm saying here in medical research and economics, but in other fields too. Right, box plots are used. They're one of the main types of graphs that you see out in the real world. So to draw a box plot, here's how we do it. So first of all, we're going to draw a number line with a scale that fits the data that you're working with. And then you're going to draw boxes by placing vertical lines at your quartiles, right? Q1, Q2, which is the same thing as M, and Q3. And then you enclose those vertical lines in a box. Then what you're going to do is you're going to draw whiskers. So you're going to draw these horizontal lines that go out from Q1 to the smallest data value and from Q3 to the largest data value, not including outliers, okay? Outliers get a special mark on our graph. They're plotted with an asterisk, okay? So let me give you an example. It says, draw a box plot of the data from 3.4 example 7. Below are the recorded speeds of the 14 randomly selected vehicles, okay? So you'll remember in example 7 here, we determined that there were no outliers, okay? So we didn't have any outliers in the data. And so consequently, we're not going to have to worry about this whole asterisk business. Like this one's going to be pretty straightforward. So what I need to do is draw a number line that goes from 20 to 40. I shouldn't do this in pen because I'm liable to make mistakes, but I'm going to say 20, 25, 30, 35, and 40. And these represent speeds, right? So this was speeds in a construction zone. So this is speed in miles per hour, okay? Okay, so now what I need to do is I need to mark my quartiles, okay? My quartiles were right here, right? 28, 32.5, and 38. So I'm going to draw a vertical line here at about 28, here at about 32.5, and then here at about 38. And then I enclose those vertical lines in a box. So what you end up with is this box that has a line in the middle. The line in the middle of the box is your median, or in other words, your second quartile. And then the edges of the box are the first and third quartiles. Okay, so that's the box portion of our box and whisker plot. We need to draw our whiskers now. The whiskers go from Q3 to the largest data value, in this case 40, and from Q1 to the smallest data value, in this case 20. Oh, I could have done much better than that. That's really ugly. It needs to go, it should go more or less to the center of the box, right? So that's our box and whisker plot. The stuff in bold that I've gone over, right? So that's our box and whisker plot right there. We should give this a title, right? We could call this speeds in a construction zone. Okay, and that would be a good box plot. Okay. Let me give you another example. This one we haven't done any work on, so we have to go through the whole entire process. So here we go. It says the following are weights in grams of 50 randomly selected quarters. You'd expect quarters to be all pretty much the same weight, but I guess there is some variability when they come off the mint, right? But anyway, it says find the 5-number summary and draw a box plot. Okay. So first things first, the data has to be arranged in order. Unfortunately for us, I think that's already the case, right? It's arranged in order down the columns, right? So if you go down this way, and then back up here and down, all of these values are already in order from smallest to largest, so that's good. This quarter must have been dirty or something. Like it had some extra weight added onto it. I don't know. Maybe this quarter was missing a piece. But anyway, so we need to find the minimum and max. So the 5-number summary consists of the minimum, the maximum, and then the 3 quartiles. But the minimum and maximum are easy, right? That's these 2 numbers right here. So that's not hard. What's a little more challenging is finding the quartiles. So we find the quartiles by first finding the median. The median is going to be the value that's right in the middle. Since there are 50 quarters, we're not going to have a quarter that's right in the middle. Instead, our median is going to be like right here, right? So if you imagine splitting the data in half, then it would look something like that. So here we've got our lower half, and our lower half, and then here we've got our upper half. Okay, so the median is right there. It should be some value between 5.6 and, well, 5.6, right? So the median would be 5.6. Okay, so that's our second quartile. Now in each of the halves we have 25 values. Okay, 25 values. So the middle value is going to be in the 13th spot. Okay, because if you think about it, right, if you pick the value in the 13th spot, then there are going to be 12 values below it and 12 values above it, right? 12 plus 12 is 24, plus the 13th spot, right, the one in the middle, is 25. So the middle value is going to be in the 13th spot. There's 10, 11, 12, 13, right? So there's Q1. It's Q2, I've got 5, 10, 11, 12, 13. So there's Q3. So my 5-number summary is going to be minimum, Q1, Q2, Q3, and maximum. And that's that. Now, we need to draw a box plot of this data as well, right? We were asked to draw a box plot. In order to draw a box plot, we need to know if we have any outliers in the data. It certainly seems like 5.49 could be an outlier, maybe 5.84 is an outlier, right? So we need to figure out if in fact those are outliers, because if they are, then that'll affect the way that we draw the box plot. So let's go ahead and figure out if we have any outliers. To do that, we need to compute our fences, okay? So the lower fence, or I guess what we should do first is figure out what the IQR is, right? So the IQR is Q3 minus Q1. That's going to be 5.66 minus 5.58. That comes out to 0.08. Okay. Now we can compute our fences. So we can say the lower fence is Q1 minus 1.5 times IQR. So that's going to be 5.58 minus 1.5 times 0.08. That comes out to 5.46. Our upper fence is Q3 plus 1.5 times the IQR. So that's 5.66 plus 1.5 times 0.08. That comes out to 5.78. So now, do we have any outliers, right? On the lower end, we would have outliers if we had values below 5.46. But we don't. The smallest value is 5.49. So no outliers on the lower end. On the upper end, we would need values bigger than 5.78. Do we have any of those? Well, yeah, 5.84 is bigger than 5.78. 5.74 is less than 5.78. So that one's not an outlier, but this one is, right? This is an outlier. Okay, so that one's an outlier. So when we draw our box plot, we're going to label this value with an asterisk. And when we draw our whisker, it's only going to go to 5.74 instead of going all the way out to 5.84. So let's draw our box plot now. We need to draw a number line going from 5.49 to 5.84. I think what I'll actually do is draw a number line going from 5.45 to 5.85. So 5.45, 5.5, 5.5, 6, 6.5, 7, 7.5, 8, 8.5. Okay. So these are the weights. This is weight in grams. Okay. Now I'm going to go ahead and put my quartiles on here. So my quartiles are 5.58, 5.6, and 5.66. So 5.58, 5.6, 5.66. Okay, so there's the box portion of my box plot. Now I need to draw my whiskers. My whiskers are going to go from, they're going to go from my quartiles out to the minimum and maximum, not including the outlier. right? So in this case, right, my right whisker is going to go from the third quartile all the way up to 5.74, because that's the largest value that is not an outlier. So 5.74 is right about there. That's where my right whisker would go. And as for 5.84 itself, that's an outlier. It gets marked with an asterisk out here, right, at 5.84. My left whisker, since I don't have any outliers on the lower end, my left whisker is going to go all the way out to 5.49. Okay, and that's what that box plot would look like. I could give this thing a title. I should give it a title. So we'll call this weight or weights of orders. Something like that. And that's that, right? So there's our box plot for the weights of quarters. Let's make sure that we can read these graphs. If we can make the graphs, that's great, but we should also be able to make sense of them. If you were to encounter a box plot somewhere in some kind of research that you're doing, you need to know how to read them. So here we have a side-by-side box plot, right? So this is the side-by-side box plots compare the pulse rates of 19 students before and after gentle exercise. What can be said by comparing these distributions? Okay. Well, we could say a whole bunch of things, right? But I think generally speaking, the trend that we see is before the exercise, the students' pulse rates were kind of at the left of the graph, and then after they exercised, their pulse rates increased, right? Their pulse rates increased, which is very, very obvious. That's exactly what you would expect to happen, right? But you can see it visually. You can see how before the exercise they were here, and after the exercise they're here, right? So their pulse rates increased. Of course, right? But I'm going to ask you some questions, and what I want you to do is think of your response and write down your response before I give you the answer. If you're looking at the before group here, what would the median of the before group be? Okay, so remember in your box plot, the median is the line in the middle of the box. So this is the median line here. If you drag that down to the number line, I would say maybe 77, 78, something like that. Okay, so the median of the before group is maybe 77 or 78. What would you say the third quartile is for the after group? Okay, third quartile for the after group. So remember the quartiles, the second quartile, or in other words, the median is the line that's inside the box. The other two quartiles are the edges of the box. So here's Q1, first quartile, and here's Q3, third quartile, right? So this is Q3 for the after group. And if you drag that down to the number line, oh, that looks like maybe 102, right? So I would maybe guess 102 beats per minute. It must not have been very strenuous exercise. Yeah, it says gentle exercise. Although this person struggled, right? This person was probably me in the class. I struggled a little. Well, so what is the value of this outlier? So the value of the outlier, maybe 145 beats per minute, which is still not super fast, I don't think. Okay, but that's that. Right, so that's how we read. Actually, that 145 is kind of fast, I guess. But anyway, but that's how we read box plots, okay? Another thing we can see in box plots is we can kind of get a sense for the shape of the distribution. So if you have a box plot where the line, the median line, is more or less in the center of the box, and the two whiskers are more or less the same size, then that's a pretty good indication that you've got a symmetric distribution, a symmetric bell-shaped distribution. If, on the other hand, the whisker is sort of, or maybe a better way to say it is, if, on the other hand, the right-hand side of the box is a little bit bigger than the left-hand side, and the right whisker is a little bit bigger than the left whisker, then that's a pretty good indication that you've got a skewed right distribution. And on the other hand, right, if the left-hand side looks like it's been stretched out, right, so the left-hand side of the box is bigger, the left whisker is longer, then that's a pretty good indication you've got a skewed left distribution. Okay. So it says with symmetric data, the median is more or less in the center of the box. And the left and right whiskers are about the same length. If the data is skewed right, then the median will be slightly left of center in the box, and the right whisker will be longer than the left whisker. If the data is skewed left, then the median will be slightly right of center in the box, and the left whisker will be longer than the right one if it's skewed left. Okay. So just filling in those blanks there with what we said earlier, looking at the pictures. But let's practice. Okay, let's practice determining if some things are skewed left or skewed right. So looking at this box plot, I would say we're starting out with a skewed right distribution for sure. And then after the exercise, well, that's a little harder to tell, right? Because your right whisker is longer than your left one, but the right-hand side of the box is smaller than the left-hand side of the box. So it's kind of hard to tell. But I would say definitely when you throw the outlier into the mix, probably this is still skewed right. So before the exercise, it was definitely skewed right. After the exercise, I would say it's probably still skewed right, that distribution. This is another kind of hard one to tell what kind of distribution you have, but again, I would guess skewed right. Because, you know, even though our right whisker is basically the same size as our left whisker, but if you include the outlier, you can see how much the sort of right-hand side of this graph has been stretched out. So I would say skewed right there. Whereas the first one, well, the first one, maybe skewed left, maybe skewed right. I would say symmetric. I would say it's probably symmetric. But anyway, so box plots. Here are some instructions for how to do some stuff that we've done in Chapter 3 using StatCrunch. And skipping ahead to your homework assignment, right? I want you to do some box plots by hand in 3.5. So do numbers 1 through 7 odd from 3.5 without StatCrunch. But then I want you to go back to 3.2 and I want you to do a couple problems using StatCrunch to do them. And then I want you to go to 3.4 and do a couple problems using StatCrunch. And then I want you to come back to 3.5, which is the section we're in, and do a few more problems, but again, using StatCrunch. And I want to see that you've actually made the box plots and histograms and stuff in StatCrunch on the problems where I'm asking you to do that in StatCrunch. So just as a, if we want to compute any kind of numerical summary of data, those are all stored in the same place in StatCrunch. They're stored under stat and then summary stats and then columns. So if you want the mean or the quartiles or percentiles or anything else, you go stat, summary stats, columns. If you want a graph, if you want a graphical display, then those are all under, well, it used to be called graphics. I think it's just called graph now. But you're going to select graph and then box plot because, of course, a box plot is a graph. So what I want to do is take you to StatCrunch and do some, just play around a little bit. So we'll do some stuff in StatCrunch. Okay, so go ahead and we'll open up StatCrunch. So you can just go to statcrunch.com and then sign in with your MyMathLab with your Pearson like username and password. And then, of course, to actually do anything in StatCrunch, you have to click this button here that says Open StatCrunch. and that takes you to the spreadsheet. I need to enter some data here. I'm going to enter the speeds in a construction zone data. Okay. I don't know if I got that in perfect, but it doesn't really matter. I just want to show you how to do some things. So let's say that you want to compute the mean of this data. So as I said a second ago, that's going to be found under stat, summary stats, columns. And then you select the column where your data is stored, and then you select the statistic that you want StatCrunch to compute. And boom, it does it for you, right? So the mean is about 32.1. If you want the standard deviation, you do the same thing. Stat, summary stats, columns, tell it what data you want the standard deviation for, and then click on standard deviation. Now, a quick word about this though. Remember that we had two different formulas for the standard deviation. One of them was the sample standard deviation, where we divide by n minus 1. And then the other one was the population standard deviation, where we divide by just n. So this standard deviation here is the sample standard deviation. If you want to treat this data like population data and compute the population standard deviation, then you need to scroll down to here where it says unadjusted standard deviation. That's going to be your population standard deviation. I'm going to go ahead and click on that one as well. Now you'll notice that if you just click on one of these things at a time, it switches the statistic that it's going to compute. If you want to compute more than one statistic, then just hold down Control on your keyboard, and then you can click on multiple statistics at the same time. And it'll compute both of these. And so sure enough, right, you see it, if you treat this data like sample data, then the standard deviation is going to be about 6.18. If you treat it like population data, then it's going to be about 5.95. So that's that. Let's say that you had, let's put some more data in here. I don't want to put in all of the quarters, but I'll just put in enough of them to kind of make my point. So whoops. Oh, those are kind of big. 5 point, I don't know, 5.9 or something. 5.6. Okay, so that's good enough, right? Again, if I want mean and standard deviation of this stuff, right, I could go to stat, summary stats columns. I could say, okay, so I want to compute for weights, I want the mean. I'm going to hold down Control and say I want the mean, the standard deviation. Maybe I want the quartiles, right? So maybe I want the quartiles, Q1. And then you'll notice like there is no Q2. That's because Q2 is the same thing as median, right? So I can just click on median and then Q3 and then hit compute, right? And it gives me all of that information. So from now on, unless I tell you not to use StatCrunch, you're welcome to use StatCrunch to compute the quartiles. And that way I think your answers will match what the book has a little bit better. But anyway, that's how you do the quartiles, right? Q1, Q2, Q3. So if I wanted the 5-number summary, let's say I wanted the 5-number summary for both of these things. So I'm going to select both of these. I'm going to hold down Control and select both speed and weights. And then I'm going to get the 5-number summary. That consists of the minimum, and then Q1, Q2, Q3, and maximum. And I'm clicking them on in order because you'll notice that that's the way that they're displayed in this box. And that's also the way that they'll be displayed when you hit enter. So anyway, then they give us the 5-number summary for each of these things. So that's how summary statistics work from chapter 3. It's really nice to be able to use StatCrunch to do this stuff. It's a lot quicker, obviously, to do standard deviation this way than to have to do the problems by hand. As far as box plots are concerned, so let's say that I want a box plot for the speed data. So then I would go to graph, box plot, speed. You want to make sure that this box is checked that says use fences to identify outliers. And then this other box that says draw boxes horizontally, you can do that or not. It's up to you. If you don't do it, it's going to draw the boxes vertically, which is different from the way that I showed you how to draw them. So if you want them to go horizontally, then you can say draw boxes horizontally. And then it'll do this. But this should look pretty similar to the box plot that we drew together on this problem in the notes a second ago. Of course, you can title this thing, right? So you can come down and give it a title and label the axes and stuff. Oh, but what I wanted to show you is that, so on this particular problem, we didn't have any outliers. So it doesn't really matter if you click use fences to identify outliers or not, right? It doesn't change the graph. But let's say that you did have an outlier. So I'm going to come back here and I'm going to change the data a little bit. I'm going to add an observation of when we computed the fences, the lower fence I think was 13 and the upper fence was 53. So let's say that you had someone just like running through this construction zone at 60 miles per hour. That's definitely an outlier, right? So if I go to graph, box plot, and then say use fences to identify outliers, then it's going to identify that observation of 60 as an outlier, right? It's going to mark it as a special case. Whereas if that box is unchecked, then it doesn't identify the outliers. We want the outliers to be identified, so we want to make sure this box is checked. The good news is that that's its default setting, right? Its default setting is for the box to be checked anyway, which is good. This is how we want it to look. I think that's all I have to say about that. So you should be able to, that should be enough information for you to be able to kind of tackle the homework problems in this section. So we'll see you in the next one.